what is it doing? So when you do your routine maintenance, you also want to start looking at other conditions of it. I know when we set up all the scheduled maintenance, you have to look to see what you have for oil and everything else. In South Burlington, Brattleboro, their routine before we had the maintenance program was to actually go down to their local auto supply and get oil in quart containers or a box of it. When they realized what the requirement of the amount of oils that were necessary and all the different types of oils, they finally asked us to come in, do an evaluation of all their oils that they needed, and then set up where they bought oil in large 55-gallon containers so that they could do the maintenance properly, and they would know that one oil met requirements for several of them. So you need to know what your labor, your parts, and what your needs are, and that's part of setting up that maintenance schedule. And then upon doing your maintenance, what was nice was we had all new equipment, but when we did Rollinsford, there's a lot of equipment that was old, needed a lot more maintenance than what the manufacturer recommended, with much harsher atmosphere, so it impacted a lot of the maintenance that was required. So you need to do an assessment, again, when you do your maintenance, keep that process. And then collect the information, what your cost is, what you're spending, and everything else. Develop, what you need in the future on that for your maintenance. So the maintenance, the reason why we do it is to maximize the life and reliability of the equipment, minimize downtime where you have corrective maintenance instead of preventive maintenance. You want to increase the efficiency. A lot of pumps and equipment become less efficient. With some maintenance, you can adjust the pump impellers to make them the weir plate differences to increase efficiencies. You can do that with a lot of different types of assets. Heating systems, just changing the air filters can save a significant amount of cost on your heating, ventilation with proper maintenance. And then as you're doing the preventive maintenance, you're actually increasing your labor efficiency because you're not maintaining failures. We need more pictures. Again, this is just the benefits of having a good maintenance program. And all of you can read that, but basically, a maintenance program is a huge hurdle for your client, especially if you do an upgrade of a wastewater treatment plant or water plant, and you drop close to $24 to $35 million worth of new assets on it, and the impact. So the more that we can do to help set up the maintenance program for the client, that benefit is that it's going to be more successful in your whole project and everything else. And that's what we realized is what were the benefits of setting up a good maintenance program and how can we help the clients on doing that. Basically, the goal of setting up a good maintenance program, and one of the ways that you can tell is where is your time being spent. I don't know how many times I go in and client, we say, oh, we need to set up the maintenance program. Well, I'm too busy because I'm repairing everything that's breaking down. We're constantly putting fires out. Municipalities, doesn't make any difference how large or small. It seems like everyone is preoccupied with just maintaining the things that are breaking. So it becomes their maintenance program is repair what's broken. The goal of a good maintenance program is to spend 75% of your maintenance time on doing preventive maintenance and only 25% reactive or unplanned maintenance. And if that ratio isn't there, then you really need to evaluate whether you need to increase maintenance staff so you can start catching up on things. But it's a very difficult process. I don't know how many times that we build a new facility and the last thing I hear is we're going to hire more maintenance people because we have more things to maintain. It's usually the same staff. So the more we can do to help them with prioritizing their work orders and their tasks, the more closer they'll be to the plan and not the reactive.
John?
Yep.
How many of New Hampshire municipalities do you think fall into that category of 75-25?
How many?
What percentage do you think?
10% fall into that category. I'm teaching a class and I asked how many people had a computerized maintenance program. And we're talking about setting up an asset management program. And a lot of it's based on a good maintenance program. Out of the class, only one person raised their hand. So getting a computerized maintenance program is very difficult. And a lot of them will have programs, but don't utilize them.
Why not? I mean, the advantages seem fairly evident. What's the argument against it?
Resources.
Yeah, it's normally,
I mean, this is what we have to overcome when we try to sell these services to our clients.
absolutely.
So what are they thinking? What's the argument against doing this?
Well, typically the argument is, I tried it. Or I've gone so far and then I ran into an issue and they stopped. And what I find is they don't have the resources to go to somebody and get over hurdles in a maintenance program.
Resources meaning?
Resources,
Money?
no, it's not always money, but an example, Dave just stopped down in South Burlington and they have all their equipment there, but they've gotten new equipment since we left. The first thing they asked was, Dave, how do I add a new piece of equipment and set it up? So even though they went through all the training, they're utilizing that software day in, day out, day in, day out. And then after a couple of years, learning how to put in new equipment has now fallen off their radar. And all of a sudden they need a resource like Dave to help them get back on track. And that's what we find out. As they get to a certain point, they get comfortable. And a lot of times they don't know what they're using the data for. They don't have an end goal. So a lot of times they'll see the maintenance not generating anything of any value. So, you know, there's a lot of reasons why people don't do it. And there's a lot of work setting it up and getting that information in there accurately.
John, is that a service we currently provide to any of our clients, putting together the actual maintenance plan, or are we just on an advisory?
Yes, and Dave will cover that.
Okay.
Because Dave went through and he actually set up 3 of them for us, the South Burlington, Brattleboro, and he set up Seabrook as well, remotely. And their issue is they can't hire a maintenance guy. And so, yeah, they come in and they have a person that says there's maintenance, but they don't do any of the paperwork. So they end up letting them go during that probation period.
John, you're never going to get to the next slide.
No, I'm not. Oh, here we go.
No, I have a question.
Okay.
Is there a client of ours that does this the best, or the best municipality in New Hampshire, and are other municipalities going to see them to learn how to do it?
Right now, probably one of the best maintenance programs is Portsmouth that we're working with. They have years of work orders and everything else. But through the evaluation of all their work orders data, they didn't have an end game in mind. They now have an end game in mind. They're modifying their work orders to make sure that they collect the data and the information that they need. You know, one of the things that we looked at was water breaks. And there was no distinction between one type of water break versus another water break. And basically the task was water break. And then, you know, what they did. But what information we need further up is, was the water break due to corrosion? Was it due to water hammer? Was it due to, you know, poor bedding? Was it due to settlement or too close to the surface during this winter freeze? You know, so that type of information becomes much more valuable than just a water break. So knowing the types of water breaks, what the information is, and by bringing the people that make decisions for CIP together with the maintenance guys that are collecting information, all of a sudden now they get a view of what they're making for information out there becomes important in supporting their funding for their assets. So when they become part of that process, that's when the maintenance becomes more improved. Reactive basically is emergency. Manchester has done some great presentations on what it costs for a water break in Manchester. You know, and what, you know, the cost can be up to $50,000 to $100,000 for an unplanned water break. So being able to take those resources from the unplanned maintenance and start moving them toward the planned maintenance is what your goal is to be able to move those resources. Predictive, you want to get to the point that you can predict what your maintenance is. Collecting the data from your work orders, all of a sudden if you know that when you've had breaks it's due to corrosion of a water pipe or due to other reasons, then you can look at an area and then by putting that in the capital improvement, replace that because of corrosion and do, you know, other preventive maintenance when you put in new pipe, wrap it in plastic to prevent it from corrosion and stuff like that. So, you know, monitoring, doing condition assessments, but a lot of the information, if it's varied, it's hard to do the analysis. But we've talked about that with the client. And, you know, looking at, you know, can you postpone it? When is it going to fail? And then a lot of times you look to see if it fails, can we repair it in a day and within our normal budget? If that's the case, you can probably let it run until it fails and maximize its life. But you have to look at your energy, your emergency costs. Emergency costs can be controlled, and if you start developing SOPs, who's going to be called, what's the cost of. So if you're able to reduce your emergency costs as well, you know, you got to look at both things when you're doing it. And then preventive maintenance is just getting out there and doing the scheduled maintenance that's required. The EPA is requiring that for your collection system and everything else. So, you know, these are some of the things that they're requiring in their permits, that you have a preventive maintenance program, that you have an asset management program. But this is the first step. This is what they look at first. Are you doing the preventive maintenance? Bridges, we talked about, you know, inspecting what they're looking for. And they're trying to do the preventive maintenance. And what the recommendation would be for repairs and everything else. These are some of the information that we collect during the maintenance to help you do a better schedule. If something's not in the O&M manual or anything, there's other sources that you need to look at. Predictive, again, we had a slide on that, and this one has a picture. But again, when you're out there and you're doing work during construction or any other time, and you cross another utility, look at what the condition of that other utility is, and provide that information to the client. You know, instead of just identifying its location, try and help them with, you know, even if it's a gas and it's not the client, you know, if it's pitted or if it's affected, that may impact their road later on down the road if they have to replace that. A good maintenance program also develops SOPs. And the best way to develop an SOP is to start with is failure. How's it going to fail? You know, it might be level of service, which might be, you know, might get physical break, but it could be that it's just not performing well. And then you look and say, what do you have for predictive maintenance? What are the alarms that tell you, hey, this is time that it's getting close to failure? And then you look and say, you know, how do we generate loop so we keep checking it when it gets to a certain point? And then what are your preventive maintenance? And then you basically work back to what your asset is. And then you now know how to develop your SOP because you have an end game is to prevent failure. So a lot of times we'll sit down and people just write an SOP, not, you know, say, okay, it's best to know how it's going to fail. And there's a lot of in between loops that you have to look at. And then your desired level of service. I mean, we were talking about a SCADA system that was fairly new, didn't provide any data output. There's no way of capturing history, but the SCADA system worked quite well and wasn't very old. It really isn't providing the level of service because you need to capture history, you need to capture trends and information. So it's really about, you know, are you getting what you need from your system for your level of service? And it does vary, again, from organization to organization. We had a conversation with the state about what the level of service expectation is in St. Thomas or Puerto Rico versus somebody in New England. And people in New England demand a much higher level of service than if you were in the Virgin Islands. You know, they'll go 5 days without water, you know, not worry about it. Now, I'm going to turn it over to Dave.
Thank you, John. So as John mentioned, we actually implemented maintenance program with both Brattleboro and South Burlington Vermont. So we provided them with an array of options for an asset software, varying the functionality of the program as well as price. So they assess the different software packages and both Brattleboro and South Burlington decided job pal is a good fit for them. So job pal is computerized maintenance software program. The important thing about any software program that you're providing to the client is that everybody in the client has to understand how the functionality of the software. Everybody's involved in the maintenance plan, so you want to have everybody being able to come back in the day and utilize the software. That way, everybody's knowledge gets put in one place.
They can't hear you.
No.
Before you go any further, John neglected to introduce you. It's possible that people in this room don't know who you are.
Okay.
So would you introduce yourself?
Yeah, I'm Dave Wheeler from the Burlington office.
Dave is an engineer with how many years' experience?
4 years.
In the environmental group in the Burlington office.
Thank you.
You're welcome.
I got a little text for you to speak up.
Okay.
Yeah.
So as John was mentioning earlier, we do these big programs with $20 million upgrade, and it's important to hand over the maintenance program with associated with all the new equipment that we are delivering to the client. $20 million in assets. There's a lot of value there, so if you're not doing your maintenance, that equipment can quickly run to failure. So we want to avoid. So, to develop a computerized maintenance management system, you want to look at both predictive and preventive maintenance as well as reactive maintenance. As John mentioned, you want to be spending 75% of your time on preventive maintenance and reducing reactive maintenance down to 25% of the time. The nice thing with South Burlington and Brattleboro is that they got all new equipment primarily in their plants, so everything was new. So hopefully they can start out by really focusing on preventative maintenance, not having to do as much reactive maintenance down the line. So additionally, on top of just setting up a maintenance program, we're also able to track costs associated with the asset. So we had some financial information for all the assets that were installed, and that was entered into our program. It allows the plant to add in maintenance costs as well. Track the cost of the asset as well.
Now, Dave, you put in the initial cost of the assets, and where did you get those numbers?
Primarily from the contractors, so it was the actual purchase price for the item, which is reflective of what it would be to replace that same asset. So, typically we tend to over-maintain mechanical assets. We'll set up an asset management or maintenance program with the schedule for every 6 months change your oil, but if you don't review your maintenance program and make adjustments, you may be doing that too frequently or not frequently enough. So we really want to include some room for the operator to make changes based on actual conditions of the plant. And we also don't want to do wrong maintenance. So if the operator goes out to do a 6-month oil change and the pump is vibrating and they neglect to look at the belts or the alignment, then they're really doing the wrong maintenance. You could be utilizing your time better to realign the pump, for example. And additionally, if they're over-maintaining the asset, and they're maybe reassembling a pump, there may be some human error in that, and so find that not all failures are from wear and tear, some are from over-maintained assets. So what we did in South Burlington and Brattleboro is we started out by inventorying the entire plant. I think for South Burlington there was something like 700 plus individual assets that we entered into the program. So it's a lot of new assets on their books that they have to deal with. So you want to prioritize what's the most important assets to take care of at any one time. As John mentioned, usually they don't have the resources to do all the maintenance. They can become quickly overwhelmed. So you want to prioritize what's the most important one to get done first. So there's different ways to prioritize assets. One of them is redundancy. You can see here a list of various pumps. Each is part of a redundant system where there's two pumps, one can be down for maintenance while the other pump is functioning. Additionally, there's health and safety concerns. You know, it's the UV system, the disinfection system with the outlet, the treatment plant, that goes down. You want to make sure that you're discharging safe effluents in the treatment plant. It's the same plastic permit violations. There may be environmental permit violations associated with certain asset failures. Difficulty to repair. You may have two identical valves, but one is buried 40 feet in the ground. It's going to be more difficult to repair. You're going to dig it out. It's going to be very expensive to replace a similar valve. It's just been building 10 times over before you replace the buried valve. Looking at cost, if you have a simple sensor that can be replaced for $50 versus a complex piece of equipment that costs $20,000, you want to prioritize which equipment you're going to be maybe allowing to run to failure, and other ones you want to maintain the asset. And bringing these all together provides a priority. So we look at the highest value out of all these criteria will come from the priority for a particular asset. So then all the assets were entered into JobCal, which has its own sheet with all the manufacturer's information. So that way you can track serial number, if you have to call the manufacturer to call them for warranty, model numbers, warranty period is important to track, whether or not you can get something replaced or you have to perhaps just try and fix it in-house. And installation date is just as important, so you know the warranty begins or it's completion. You can see there's a place for the original cost of the asset, and then you can also connect each piece of equipment to the SCADA program if they have that functionality, so it can track the runtime of the asset. So a pump might be on for 8 hours a day, maybe running 24 hours a day, so that'll be tracked. And then we looked in the O&M manuals provided by the manufacturers to get all the various maintenance tasks associated with each piece of equipment. And again, we prioritize these as well. So changing the oil versus maybe an annual inspection for vibration, replacing bulbs on the UV system, and we assign a priority to each task, again, depending on the consequence of failure, the criticality of the piece of equipment. So these two priority numbers are then multiplied together in JobCal, and it provides a work order priority. So here you can see how the tasks are scheduled. The frequency may be weekly maintenance, monthly, semi-annual, every 5 years, every 10 years, and the program can track that, or it can track frequency in meters. So if it's based on hours, every 8,000 hours of runtime, you have to change an item, and that can be tracked as well. So then you have a screen that displays all the maintenance tasks that are scheduled for that day based on frequency. And you can order these based on work order priority. So you have the equipment priority, you have the task priority, together you make a work order priority. So if you're perhaps you're understaffed, you're busy that day, you have 26 items on your list to do. You you know you're not going to get through them, and you can sort them by priority and focus on what's most important at that time. You can also push items out to tomorrow if you're unable to get to them today. And if you leave them day by day, it will show turn from the bluish green to yellow to red, indicating these are long overdue. And this can also be used for a plant to indicate that they're understaffed. They need more assistance to get all this work done. So here's an example. We had a sludge pump, and the task to be done was check the pump oil levels and then fill them if needed. And Devin in South Burlington completed the task. He found there's 2 pumps. One of them needed its oil level to be filled up, topped off. The other pump was okay. So what he determined from that is that one pump had a different priority than the other pump. The pump that was going through more oil had a higher priority, so he increased the frequency of that task. So it's going to maybe pop up on the screen every 3 months as opposed to every 4 months. And then you can pay attention to the pump that is already beginning to fail versus the other pump that is still in good condition. So in addition to preventive maintenance work order tasks, the operator can also enter in preventive maintenance. So if he was out in the field checking his oil level and another pump went down, and that day he had to rebuild something, he could go in and enter a corrective work order, and that allows them to track all the work they've done in the plant. So when they go back later, they can generate a report for every single piece of equipment in the plant, and it'll show all the work that they've done, and they can see that one of the pumps has not only had oil level issues, it's also got issues with the bearings, and it's not operating at proper capacity, or it's going to power or something like that. And with a combination of corrective maintenance and preventive maintenance, that can all be grouped together.
John ended the meeting.
Alan says he'll just watch the recording,
Recording?
Yeah.
Okay.
since you're recording it.
I am.
We were having technical difficulties, but
The go-to-meeting ended.
John.
Yeah. Look for the mouse.
are there any questions about what we did in South
Is
Burlington?
there like an app or an iPad for this? Or is it have
I believe there is Droptail. They have a mobile.
They have a mobile device.
Yeah.
But more and more of them are becoming more Wi-Fi, where you can be connected or disconnected to the maintenance program. Because this is a computerized maintenance program, it's not an asset management program. It's mostly for facilities. So people normally bring up their work orders, go out, do work orders, come back, and then input the data into it. It cannot be really easily accessed for viewing, but you can generate reports from it. So you can generate the cost. When he shows the work orders, one of the options is to skip work orders and just put them into history, so you can look at how many work orders were skipped and what the man hours required to do all the skipped work orders. And by doing that, you can estimate how many man hours was needed to actually do the work you didn't do. So it's really what's happening, and which Dave did a great job, was when you start looking at all the required preventive maintenance, it just cannot be done typically with the staff that is available. And the documentation, without the documentation, you don't get more staff. And typically, maintenance people will do the maintenance, and then those are the work orders that are generated, and that's it. So you don't see what they don't get done. It's like doing a to-do list at the end of the day. You write down everything you did during the day. You complete the to-do list every time. It's like, oh, I got everything done. That's not what's happening. In reality, we're not getting to all the preventive maintenance. We're not investing. Probably the biggest investment for a good asset management program is having staff to do the maintenance, and having good staff doing the maintenance.
So John, along with like what Bob said, you said it was like 10% of the places actually do have a system that they actually do this?
Well, a lot of people have the system, but Bob asked how many of them have the ratio that they spend 75% on their preventive maintenance and 25% on corrective.
I mean, I'll come to, I think, all of these things so far. One of the things I get is that it seems like there's an immense amount of data that goes in there. But then we get to a point where we say, well, they can't keep up. And so, I guess I'm looking at the thing saying, what are these people achieving in the end? I mean, in a place like Portsmouth that's doing a really good job, what sort of cost savings are they getting over what they were doing before? Something like that.
Yeah, and there is a lot of good data on cost savings. There's just not a good amount of data in the United States. Most of it is Australia, New Zealand, Canada. Right now, in the United States, probably out on the West Coast, they're starting to collect good data and do it correctly. New England is very spotty. It's not. There's great potential here in New England, but because of smaller organizations, they don't tend to have the same structure, because we're a small community type New England. So it's more difficult to have the organization and the staff to be able to do it. So it's a challenge.
So what do you have to point the data from, like Australia or something, to say, look, if you do this and do it well, you're going to
This
get
is what they
savings
say.
of this?
Right. Yeah. And I know Columbus, Ohio has shown tremendous amount of savings through their program. And they do a lot of not only preventive maintenance, but they have purchased a lot of equipment to do predictive maintenance. So they actually stay ahead, and each year they generate reports showing how much money they have saved through the program. And the mayor actually does a special report on asset management and the savings that is implemented. So they, to have a successful program, everyone from upper management all the way down through has to be part of that program. There's not a feeling that the data that I'm collecting out in the field is helping me in the long run with the capital investments that I need. It doesn't continue to flow up. So everyone has to be on the team.
Actually, John, you said something interesting.
Really?
Interested me just now.
Ouch.
Yeah, this is yours.
Once in a while.
John, this is yours one.
Yeah.
New England, for environmental New England, is a different market than most of the country.
Yeah.
Because we're Yankees and every little town and city likes their own thing. We don't have big regional systems. Really, you can count them on one or two hands in New England. Unlike most of the country that operates with strong counties, for example, that do a lot of things. Is that a hindrance to going out and selling these services, because there's so many small systems, they don't see the need for it, or it's too painful to implement and actually use? It's less painful just to do, by seat of the pants.
It's more painful to do it. Doesn't mean that they shouldn't understand it. It's an educational process that occurs. Other things that occur in New England is a lot of times there's political turnover. And there's redirection every 2 years based on your political entity. So that becomes also part of having continuity from the guys in the field versus the goals of the leadership. So through the training, and I think through a good leadership in the community, I think these programs can be implemented at all different levels. There's a lot of different tools.
The E.I.T is a tool for small communities to utilize.
Yeah.
What kind?
It's a checkup system.
Yes,
checkup-
cups.
Checkup program for
Yeah.
small systems. So,
Dave's certified
Facility,
and trained.
for facility maintenance or for?
It's facilities,
asset
but in Vermont, they had developed it so that they could do horizontal assets, and they import it from the GIS. So basically, it's communicating with their GIS into the maintenance program, so they can do it and then back again. And they have a template for what can be imported. It's a little awkward to use, and when you start bringing that many pieces of equipment into the CUPS program, you end up having, it's difficult to manage.
What was the, excuse me, the maintenance software was called, so, what was it called? Jackman. And what's the, like, for a wastewater treatment plant, you typically recommend one seat of flat software, or dedicated workstation?
yeah, I think we installed it on a handful of computers. So, you want the superintendent, for example, might want to be able to print reports showing all the units that was done that year, or man hours, but you want the operators to each have the ability to input work they've been doing every day, which is important because you get a guy that retires, he leaves with all his information and he's stealing over the years. So you want these operators putting in as much data as they have into the system, so they stay for the next guy.
And that's what happened in Seabrook. Their maintenance guy left, and no one knew how to run the maintenance program.
How much does the software cost?
You remember? Probably, yeah. And that included the connection to the SCADA,
How much? 30.
about 30.
And that's a site license, so you can have multiple seats.
Right. Yeah. And then there's an annual fee on top of that, of course. Yeah.
So John, just to walk through it, because you're always trying to think about how these are kind of developing the way for oil tanner. So a community gets an NPDS permit with a CMON requirement. They say,
Yeah.
okay, we need to get all this together. So do you have anything sketched out, sort of like a flow chart for us to kind of talk them through where you need to be and this job cal, the one to be used, those kind of things?
Well, for Pembroke,
Yeah.
we are hired to do the CMOM. But part of the CMOM, we ask them how are they going to do their maintenance?
Mm-hmm.
How are they going to track their costs? How are they going to do capital improvement planning? How are they going to do this? And by going through the CMOM, they give you answers. And then you kind of look and say, well, but that doesn't meet the requirement. And you go back and forth, back and forth. And with Pembroke, we implemented viewers. And they were able then to put in their equipment, some of their costs, and now do their maintenance. At the same time, they're doing inspection of manholes and stuff like that. So they utilize that to comply with their CMOM requirement. But as writing it, theoretically, we could have written the CMOM program in 3 months.
Tom, what's a CMOP?
It's a, go ahead.
Just basically the maintenance system for your POT, public
Yeah.
works
What's it stand for?
facility.
There's people in this room who have no clue what a CMOM is.
I know it.
They see their mom occasionally,
Yeah.
but
Okay.
And that's what it is. You see your mom. It's capacity, maintenance, operation, and management collection system.
And so then that's what so we can do that for them, we say we can help you with this, and our fee is to set up this whole program, that's what our task would be, right?
We set up, depending on what they have available for data.
Yeah, okay.
And that's, you really have to find out where the client is. Do you want us to go on to the second? Thank God Nicole's here. Okay.
22-foot boat, now you're talking.
Yes. Oh, here, let's see if that shows right. Look at that. Okay. Good. That was on. Okay, this one we'll go through quicker because life cycle costs. We were talking about how exciting a topic it was. So if you thought maintenance was exciting. Okay. So what we're going to do is life cycle costs of my brother's boat, and then cost perspective, direct life cycle costs, financial, social, in developing a life cycle cost, and what's the value of your assets. So you kind of, this is what we're going to try and cover today. And so what I did was, my brother bought the boat 10 years ago, and that had about 150 hours on it. So I was like, okay. Most of the time it just goes down the lake and just sits, with the engine not running, but we have to look at what the initial cost is, and when you start doing life cycle costs, it's whatever the construction cost is, the acquisition, and then whatever fuel cost. Right now, John Riley's doing pump station, so he looks at what the electrical cost will be each year for that pump as part of the evaluation. Operation and maintenance costs, repair costs, replacement costs. So if you look at, what are you going to replace? Is there any residual value? I don't know about bridges, but usually when they're gone, they become an expense more than any residual cost. And then whatever your financial, if you're borrowing the money, what is the cost of borrowing the money, your expenses, and any non-monetary benefits that you're getting out of it. Okay. So my brother bought 22-foot boat, cost him $32,000. Then the slip for the boat for the year cost $2,500. So over 10 years, $25,000. Then you register your insurance, $350 each year, and then winter storage, $2,000 a year to pull it out, and then wrap it and everything out. And then getting it ready in the spring, $400 each year, so all of a sudden $4,000. And then fuel fill up, $250, and I don't know how many times you fill it up, but then of course you need your life jackets, your skis, all your toys to get into the boat. They spent $5,000 there, and then of course during the 10 years the rear end went, and that was $3,000 to repair it.
So your brother's crazy, right?
Yeah, well, you figure out, you got a really good 150 hours out of this. So, then you go on and you kind of break out your life cycle costs, Where are you spending all your money? Well, your capital costs, there too, but your operational costs, which is the storage, is $45,000. So all of a sudden your operational cost is greater than your capital cost. Your energy cost, you ended up filling it up, I think, 20 times. So that's $5,000 in fuel. And it is funny because you say, oh, I got to not spend so much money on my boat. So what do? You use it less. And then your life jacket and all that. So you kind of break out what your life cycle cost is. And we haven't even talked about disposal of this boat, because he still has one boat that costs money to get rid of, which is sitting in my backyard.
Sounds like he knows what he's doing.
That's right. Yeah, because nowadays you have to cut the boat up and throw in the dumpster.
This story's really about you, isn't it?
Well, it's about Nelson too, but we won't even talk about that right now. Because Nelson, I'll say that. So replacement cost, this is what the definition of replacement cost. So when you're looking at, I don't know how many plants we go into and walk into an area, and there's equipment that hasn't been operated for 10 years. And the reason why is that they didn't budget money to get rid of it. And they don't look at the value of the floor space as value. So there really is value. If you actually got rid of it, you would probably look at other opportunities that you'd be able to do. So, replacement cost is, you need to look at that in the long run. And if you have it in your plan, you typically will follow through and take care of it. So, as we go through with replacement costs, you want a bigger boat. And after you've done this analysis, it's amazing how many people buy bigger boats. Your wife wants to get rid of the boat, so that could be one of the options. And then, can you even afford to keep the boat? Pretty soon you're spending all this money, and what do you normally do? You end up saying, okay, I'm not going to pay for storage, I'm going to save money. So all of a sudden you leave it in the backyard and it gets rain and the snow gets in there and more damage occurs. And because you're not maintaining it, all of a sudden you're spending more money on maintenance. So you think about that. Or you just rent a boat when you need it. So when you're looking at an asset life cycle cost, look at different options. What does the client have for options? I know when we did the bridge in Rochester, the town wanted to know what was the cost of different aspects of that bridge. And they hired us to put the cost together so that they could put those costs into their financial information. Of course, this is where the Nelson comes in, and he got me a free boat because he wanted to use my boat. I can't. Thank you. So these are the direct costs: your acquisition, your operation, maintenance, renewal, repair, rehabilitation, replacement, and your disposal. Okay, these are your economical costs, your financial costs, cost to your government. Which when we look at life cycle costs, it's more of looking at it when it's not operating. What is the cost? But there's also the cost of the loan, direct cost to the customer. It's basically if they don't have that asset, what is their cost, and community cost, and then financial, economical, social, environmental cost. So everything has a cost, and you have to look at all of them to also understand when that asset fails. And when it fails, that's when your life cycle cost ends, and that's your cost. Okay. Also, it's important to know that as it gets older, your maintenance and operational costs increase. And then you do a rehabilitation or renewal. And then, you know, your operational costs will stop down again and slowly start going up again. But your life cycle cost is the cumulative over the life. So, and then your disposal cost at this point. So it's, life cycle cost isn't really complicated, but it's hard to collect the data and put it together. Really part of it is collecting the data from your maintenance system to understand what the life cycle cost is. Okay. It's also important to understand the trending. When you start doing asset management and you start looking at which assets you can run to failure, you also need to understand that the operation and maintenance costs increase when you decide that to run to failure. Your goal is to run it to the point that when the operation and maintenance cost is at the point where replacement cost is equivalent, and then you replace it. And that's you're maximizing your investment is at that point. Okay. And I was, told my kids, maximize the life of any asset. And I told them that's why they were still driving my car, and it went through all the kids, and they were still wondering why that car was still on the road. I was maximizing my life cycle cost of my vehicle, and it's not because Dad is cheap. So they finally told me that I'm now frugal and sustainable. So I've moved up. So now the cost of maintenance, when it's greater than replacement, Dover does a great job tracking all their maintenance costs for their vehicles. And when it gets to the point that the maintenance cost is greater than replacement, they have a great replacement program. And they also move vehicles around to areas to make them more efficient. Energy costs, we were talking about one of the things that humans don't tend to do. They just had a story on public radio of life cycle costs and why people don't make investments. And that's why the government's doing rebates. If you buy economical light bulbs, they have a rebate, when in fact, if you bought it and replaced it, you would save money anyway. But there needs to be incentive for people to save money. They have incentives for, getting more insulation in your house, but in fact, if you just did it, you would still save money. They were talking about people to save water. More than likely, the things they do is they start taking shorter showers, stuff like that, when in fact the best investment would be to replace the toilet. So life cycle cost, the tendency is not to do the most economical thing for you, but to do something that you seem to get a quick response immediately. Like taking shorter showers automatically lowers the water bill, but making the investment for the new toilet would pay for itself and would be a long-term savings for water saving. So these are life cycle costs that occur in our lives every day. And when it no longer provides a level of service, when the toilet costs more than it does to replace it, then it's no longer meeting the level of service because of the economics of the thing. Basically, the cost to the government is typically all that we look at when we're doing life cycle costs. And those are the costs of repairing, maintenance, and the pipe breaks in the middle of the road, they say, well, it cost us this much money for manpower, equipment, it cost us this much money for road repair and patch, and then all of a sudden, and some lost productivity. But what we don't look at is what the cost is to the client. I drove in on a road for close to a year and a half where it was just potholed and just falling apart. And the town says, well, we can't fix it, Well, they went through and they estimated the amount of vehicle damage that had occurred over that year and a half from potholes, realignment, tire damage, and everything else. And because that doesn't show up on the tax rate, it doesn't show up. But in some countries, if there is a loss of service to the customer, they're reimbursed for that. So they actually have a true cost for the social impact to having an asset fail. So again, what are some of the other social, not direct costs, right here? Environmental, emotional. I don't know how many people complain about that road. So, you know, this is a cost as well. In Somersworth, we actually did a social cost in our program when we did the condition assessment. And what we did was we broke out if there was a cost for a repair for a water break, we have $5,000 for the repair, that's the municipal cost. But for every resident to be without water, it was $150 per day for that resident. We based that on the fact that if they didn't have water, they would have to go out to dinner to eat. So we just put in a number. For a store to close down, for most of the stores to close down for the day, we estimated that they lose $1,000 worth of business for that day. And for businesses, we put in $5,000, but if we talked about really specific, enforcement, if they're down, they lose $1 million an hour for that business to be without water. So the cost to the customer can be huge. For a small toy company from Somersworth, with $30,000 an hour that they would lose without water. So you have to know what your cost is to your customers so that you can make better decisions on which assets that are critical and need to maintain and what is the social cost. Tracking your costs, again, for your computerized, your accounting, your finance department, and basically it's a data collection, again, collecting all the information, looking at your direct costs. You know, it's very difficult to measure the social cost, but I think it needs to be discussed, and we should try and put a cost to that as well, to allocate costs. And most municipalities, for their costs on their records, they show depreciation over the life of the cost. Many of them have that cost disappears long before the asset has been expired. So that cost no longer occurs. So what some asset management programs do, they put in a depreciation cost plus CPI. So you're actually continuing to theoretically experience cost through the whole life of the asset. And if you fund it, then you'll actually have a CIP budget for replacement when you fix it. different ways of developing costs. I want to get to Dave here. Key points when you're looking at your life cycle costs, you're looking at extending life, so it can be repairs, rehabilitation. Each one of those things can extend the life of an asset. So you're trying to move out, again, extend the life as long as possible to get your life cycle costs. And these are some of the things. These are fine. Let's go to Dave from Burlington, Vermont.
Thank you, John. All right. So not only do we have to teach everybody at the plant how to use the software, but we want to teach them the value of using the software too. If everybody knows how to use it, and nobody knows why they're using it, they're not going to use it. So, when the operator comes back from completing a work order, he can enter in costs associated with that maintenance task. So if it took 2 quarts of oil, he can enter that in. If they have the cost of that oil on hand, he can put that information in as well. They can also put in their labor costs, so how many hours did it take them. And that's important because they can use that in the future to understand how many hours of work they have ahead of them based on all the work orders that are showing up on a calendar. So the labor cost and the inventory cost, and then any other miscellaneous costs gives them total cost for that maintenance completed that day, that asset. And then superintendent or somebody at the plant, they can generate reports from job cal, so they can look at each piece of equipment and they can get all of the costs associated with all the maintenance from that year. So that's very important for lifecycle costs. That way they can look at their operation maintenance costs and see where that meets the replacement costs, which we also had included based on the initial price of the asset. So if you're not tracking this information, then you're likely just going to go right past that sweet spot